This video, I'm going to show you how to do a genetic dissection and use that to construct a biosynthetic pathway in a very quick way. This is the way that I found that always works, so I hope that you find this helpful. So the intermediary, or the top row, which is this, you need to memorize that the less amount of pluses goes first, and through that I mean you're going to look vertically at the table, and to find where to place the mutants on the arrow, you need to memorize that the less amount of plus mets or mutants goes last, and for that you want to look horizontally. So let me explain what I mean. Let me zoom out a bit. Okay, so to first find the intermediaries, you have to look vertically, and the less amount of plus goes first. So let's start off this way. So less amount of plus, okay, I see. Look at this way. So in this example, it's pretty easy because they all increase in increasing order. So middle medium has 1 plus if you look it down vertically. Cysteine has 2 pluses if you look down it vertically. Cystathionine has 3 pluses if you look down vertically. Homocysteine has 4 pluses if you look down vertically. And methionine has 5 pluses if you look down vertically. So if you arrange that in increasing order, and here I wrote that the middle medium is homoserine, we can construct it this way. So homoserine, cysteine, cystathionine, homocysteine, and finally methionine. Okay, so great. We found the intermediary, and now we want to find where do we place the mutants. So to find the mutants, you have to look at the table horizontally, and for that I'm going to use brown. And the rule is the less amount of plus mets goes last. And by last, I mean whatever you wrote down this way. So let's see. So we see that met 1, met 1 has 1 plus. Met 2 has 2 pluses. Met 3 has 3 pluses. And Met 4 has 4 pluses. So remember, for mutant placements, you look at it going last. So here, Met 1 followed by Met 2, Met 3, and then Met 4. And that's so this question is a bit different than the one above because everything's not in order, but let's see if we can still tackle it. So to find the intermediaries, we know that the less amount of plus goes first if you look at it vertically. So let's divide it vertically. D, F, M, R, S, and then we have this ZMT at the end. So less amount of plus goes first. Okay, so we know that D, if you look down at it vertically, has 1 plus. And then let's see what has 2 pluses if we look down vertically. See R. Oh, is there 3 plus? Yep. If you look down vertically at M, you see that there's 3 pluses. So DRM. what is there 4 pluses? Yep, on the column F, we see that there are 4 pluses. So F, and then we see that S has the most pluses. And all that forms the pathway to ZMT. Great, so we found the number of intermediaries. So now we want to find where to put the mutants. So now let's look at it horizontally. So we know that the less amount of plus mets or mutants goes last. So let's see what has the least amount of pluses. Well, ZMT1 has 1 plus if you're stopping at S, but if you're stopping at ZMT, it has 2. So either way, you'll arrive at the same answer, but I'm going to stop at S. So let's see. So for ZMT, we see that ZMT1 has 1 plus if you look at it horizontally. So I'm going to put that here. ZMT1. Let's see if is there any way that has 2 pluses. Yep, right here. ZMT3, we see if you look at it horizontally, it has 2 pluses. So ZMT3. Is there anywhere that has 3 pluses looking at it horizontally? Yeah, we see ZMT4 has it. So ZMT4. And lastly, we see that ZMT2 has the most pluses if you stop at S at the pathway, which is 4. So ZMT2. And yeah, that's all there is to it. I hope you found this video helpful, and let me know if you want to see more problems like this. So in this question, we're asked which step is catalyzed by the enzyme responsible for all the mutants: MET1, MET2, MET3, and MET4. So remember, when dealing with the mutants, we look horizontally, and to see what's catalyzed, wherever a minus turns positive is the answer, and the reason being it leads to that. Or you can simply remember the rule that we've been dealing with. So let's see here. Remember, when we're dealing with mutants, we look horizontally and we start last. So this one is MET1. This one is MET2, MET3, and MET4. And I got MET1 because there's 1 plus here, 2 pluses, 3 pluses, and then there's 4 pluses here. So now, let's see what happens. So let's talk about MET1. So for MET1, MET2, MET3, MET4. So for MET1, we see that it's homocysteine to methionine. So homocyst. I'm going to abbreviate homocysteine to methionine. Now let's look at MET2. So for MET2, it's cysteonine to homocysteine. Cysteonine to homocysteine. Now let's see MET3. MET3 is cysteine to cystathionine. And let's see, for MET4, it's homoserine to cysteine. Homoserine to cysteine. That's a C. And yeah, that's all there is to it. Luckily, here we were given the intermediaries. But like I said before, if you didn't know that, you can remember the rule that to find the intermediaries, the less amount of positives or plus goes first, and you look vertically for that. And yeah, that's it.